In this video, we're going to review solving systems of equations by substitution. This topic is important for us because it's one of three main strategies for solving systems of equations in this unit. And after Math 10, this is typically the most common strategy that you're going to see for solving systems of equations. This topic is also particularly important if you're going to be taking Pre-Calculus 11 because it's going to help strengthen your algebra skills, and that's going to be an expectation for that course. When we talk about solving by substitution, we often refer to it as an algebraic method of solving. That means that we use algebra to help solve. In the method of substitution, we find an expression equal to one variable. So, for example, I might have already done some math to figure out that x is equal to 2 apples, and then we substitute that into the other equation. Right now my other equation isn't complete, but for this first example, we know that 3 apples and 2x are being added together. So we can take what we know x is equal to and substitute it into the other equation or other expression for x. The advantage now is that what we are left with involves only apples, and now we can use our algebra skills to multiply 2 with 2 groups of apples. We've gotten a little bit closer now that we know we have 4 apples being added, and we can say that altogether we have a total of 7 apples. Now let's take a look at this in a little bit more detail. When we solve by substitution, our first step is to rearrange one equation for a variable. You might hear some tutors or some other teachers explain this as isolating a variable. Once you have one variable all by itself, we substitute the expression that it is equal to into the other equation. This means that we end up with an equation that only has one variable left in it, and we can solve. Lastly, once you know the value of one of the variables, you'll take that answer back to the first equation, substitute it in, and solve. Now, like a lot of things in math, this is going to make more sense with some examples. In this first example, we're asked to solve the system of equations y equal to 2x adding 3 and y subtract x equal to 6. Now remember, when we ask you to solve, we're asking you to find or figure out the values of x and y that will make both of the equations true. Our first step for solving by substitution involves rearranging or isolating to get one variable all by itself. Conveniently, this y is already all by itself, so we've been saved some work. We're going to take the expression that y is equal to and substitute this into the other equation. Now we treat this like one of our equations from algebra review. We'll do any multiplying that's necessary. In this case, there isn't anything in front of those brackets, so we don't need to worry about multiplying. We're going to combine our like terms, 2x is subtracting x, and keep solving until we figure out what x is equal to. When I look at 2x subtracting x, I find out that it is equal to 1x. There's nothing to combine with the positive 3, that stays the same, until we decide we want to undo adding 3. So to finish solving, we're going to subtract 3 from each side of the equation. Now we find out that x is equal to 3. We're going to take that answer and use it in the first equation in order to find the value of y. When we substitute 3 in place of the x, we find out that y must be equal to 9. So that coordinate point that makes both equations true would be the place where x is 3 and y equals 9. Before we decide that we're done this example, we should check to see if there have been any algebra mistakes. The simplest way to do this is to take our values of x and y and substitute them into the other equation again. I just used this equation, so for our check, we will use the other. When I test x equal to 3 and y equal to 9 into our equation, we find out that 9 subtract 3 is in fact equal to 6. At this point, it's also helpful to know that you may see some people when they perform their checks draw a small question mark over the equal symbol since we're not sure that it will work out, and other people when doing checks will use a vertical line instead of equal symbols. Any of those three approaches are totally acceptable. Now let's try solving this system of equations. This is a little bit more complicated because we don't have a variable already isolated, and we don't even have a single group of one variable anywhere. Some students will look at the 2x in the second equation and think about how dividing by 2 is going to leave us with a pretty friendly equation. Other students might notice that the first equation has a common factor of 3, and everything can easily be divided by 3. Either one of these is a great approach and will leave you to a lovely final answer. For our example today, we're going to look at rearranging the second equation. Looking for a division that will lead us to friendly decimal numbers is a good pattern to get into, since that will always work for us even when there aren't common factors. So we subtract 6y from each side of the equation, and then divide the entire equation by 2, in order to find out that x is equal to negative 3y adding 9. Now we're going to take this expression equal to x and substitute it into the other equation. We find out that we're looking at 6 groups of negative 3y adding 9, adding 3y equal to 24. Now we'll use our distributive property. 6 groups of negative 3y leaving us with negative 18y, and 6 groups of 9 giving us 54. We'll finish off the equation and solve. Take a moment to look through the rest of solving this equation to make sure that you're comfortable with finding out why y is equal to 2. Now we're going to take that answer back to our first equation to find the value of x. Since x is equal to negative 3 groups of y, or negative 3 groups of 2, adding 9, x must be equal to 3. And the solution to this system of equations, we believe, is at 3 and positive 2. Before we leave this question, we should do a check. My last solving involved this equation, the x adding 3y plus 9, and that was based on the bottom piece. So I'm going to use the top piece to do my check. When I take a look at 6 groups of x, adding 3 groups of y, that turns into 18 adding 6, which is actually 24. My check shows me that my solution is correct. Let's take a look at one more example. Once again, we don't have equations that are already rearranged to isolate one variable, so we're going to have to do a little bit more work. And in this case, we don't have any common factors, so let's choose a variable and an equation to work with that will leave us with very friendly decimal numbers. Dividing by 3 isn't going to leave us with terribly friendly decimal numbers, so we probably don't want to rearrange the top equation for x. Dividing by 4 will leave us with friendly decimal numbers. We could use either the top or the bottom equation to isolate y, and dividing by 5 will also work quite nicely. In fact, dividing by 5 is going to give us numbers that only take one place after the decimal, so that'll be what I do this afternoon. When I rearrange, I find out that x is equal to negative 0.8y, subtracting 2.4. That was based on the bottom equation, so I'll substitute this into the top equation. As we finish solving, we're going to combine our like terms, the negative 2.4y and the negative 4y, to find negative 6.4y. We're going to have to add negative 7.2 to 12, divide both sides by negative 6.4 to find out that we believe y is equal to negative 3. We're going to take this answer back to our first equation. As we work through that first equation, we solve to find out that we believe x is 0. So we believe that our solution is at 0 and negative 3. Once again, this is an appropriate time to check before we decide that we're finished the question. Our check shows us that our values of x and y work in the equation that we didn't just use, so we know that we have a good solution. In all of our examples in this video, we found one solution, and that fits with most of the options, similar to when we were solving by graphing. When we were solving by graphing, we did see that there were other possibilities. When our graph shows us parallel lines that never intersect, we say that there are no solutions. Some people may refer to this as an inconsistent system of equations. When our graph shows us 2 lines that end up directly on top of each other, we said that this was a system with infinite solutions. And again, you may see some people who refer to this as an equivalent system of equations. In terms of the algebra, When one of these systems happen, we see some funny things happen with the algebra. You might see 0 groups of x equal to 8, which is impossible to solve, or 2 is equal to 1. Or you might end up with very straightforward equations like -5 is equal to 5, or 0 is equal to 0. If you end up with a weird kind of a work in your algebra, it might be a good idea to rearrange and graph on your calculator to check for these inconsistent, equivalent, or no solutions, infinite solution scenarios.